Hi, students. So, last time in our last lecture, we discussed the basic hand tools, basic systems, which involved hand tools. Now, today, our lecture will be focused on mechanical systems, meaning power devices, meaning devices that function through the use of electricity and power. So we will discuss some important things that needs to be considered, whether you analyze a device to find design mistakes, or whether you design a new device to improve or solve the design problems. Now, so before we start discussing devices as a whole, we need to know what are the components, what makes up a device, what usually we have in a device, okay? That is important, and that comes in contact with the human, okay? Because remember, we're designing, everything we're designing is for the human, okay? To fit the human needs in terms of body size, body needs in general, okay? So we need to know all of these parts that in a device that come in contact with the human. And then when we know them, these components, we need to talk about them separately, one by one, and discuss what are the important things that needs to be considered in analysis or design for each of these components. We cannot discuss in general. We explained this before. We cannot discuss, like, look at the device and tell me the design mistakes in it just by looking at it. We cannot know that. We need to consider, we need to break down the complex situation into small parts and look at each part separately to understand what are the important things for each of these parts. So now the basic components of mechanical systems, meaning power devices, we have displays, we have controls, and we have something called the interface, okay? Now, I will discuss each one separately. Today, we will focus on controls, meaning what are the controls? The buttons, okay? The buttons that we press on a device. Now, but before we start with the controls to discuss about them, we need to take a general picture. So what are displays? What are controls in general? What is the interface in general? And then we will start focusing. Okay. So controls are the means by which information is transmitted to the machine from the human. So if I want the machine to do something, how do I tell the machine to do whatever I want? By using controls. So if I want to tell this, for example, a machine to start working, I will have here somewhere a start button, on, off. So if I press on, I'm telling the machine, please start work, okay? If I press off, then please stop work. So controls, which are the buttons usually, not only the buttons, however, okay? A machine, for example, handle can also be a control. But we are focusing now on controls that are buttons, okay? Like these. Now, so controls are a way for the human to transmit information to the machine. Okay, I transmitted the information. I'm clicking, for example, here, some buttons. Now, the machine needs to give me feedback, okay? Now, if I click here some buttons and there is no feedback from the machine, I will not know if the machine is understanding me, okay? So how does the machine communicate to the human? Through displays. This is a display, okay? So if I'm clicking here something, okay, the display will give me feedback. So it's a cycle, okay? So I give information to the machine through the controls. The machine gives me feedback through the display. Now, the controls and the displays usually are present in most machines. Controls and displays of some type. They can be totally different in design, in shape, in color, in order, but this is the things that we will discuss later. How we can know, for example, what are the problems in this design? What is the problem with the display? What is the problem with the controls? What is the problem with the way they are ordered here? Is this size maybe too big or too small? Are these colors with the background color a good choice? Many things, okay? We will discuss. So we have controls, we have displays. Now, what is the interface? So, sorry, let us look at these pictures. So controls here, as you can see, many examples, many shapes, many sizes, many colors, the way they are ordered, okay? Here we have displays. Again, many examples, many shapes, many types. Okay, we will go over these later when we talk about displays in more detail. Now, the interface. The interface, now the controls and the displays are organized onto something. So they are organized, so all of this is called the interface. So we have a display, for example, here we have controls, and they are organized in something called the display. The interface. So the interface is all of this, the displays and controls and the way they are organized in this space. In this, for example, this is the shape of the device, how they are organized in here. This is another shape here. We have other shapes here of devices. Depends on the device, okay? How are they ordered in? So this is called the interface, the displays and the controls together. How they are grouped together, organized means. Okay, now, if you have taken the other class with me, the basics of design, if you remember, we talked about shapes, the elements of design, shapes, colors, lines, all kinds of elements of designs. If you notice, well, when you look at any device, okay, you will also see the elements of design present. So here, for example, we have a shape, a rectangular shape. Here, another shape. Here we have circles. We have here smaller circles, bigger circles. So when we discuss the principles of design, we discussed size, we discussed all kinds of things, okay? Balance, contrast, okay? So we have all of these things in a device. So when I mentioned before, in products, okay? In anything you design in this world, whether products, whether posters, I mean two-dimensional designs or three-dimensional designs, you will use elements of designs and principles of designs. This thing you must know because this is applied here as well. Just here, we have other guidelines also that we will explain in addition to the things that you already know from the basics of design class, so that devices can be made ergonomically suitable for the human use. But when you come to the design, if you look at any device, you will see the basic elements and they are organized in a certain way. They have different sizes, different spaces in between, different. So we have elements of design, principles of design, always, okay? In any design. This is to remind you, okay, the application of what we study in other classes. Okay, now let's get back to this, okay? So the interface, how all this, the displays, the controls are organized, okay, together in this space. Okay, now let's focus on controls. All of our explanation in today's lecture will be focused only on the controls. So normally the hands and feet are the body organs that are used, or the body parts, I would say, that are mostly used to operate controls. So if I want to click a button, okay, if I want to rotate, okay, this is also a control. Now, what do I use? What's the human machine touching points? Well, it's my hand and my certain fingers, okay? Sometimes I use also my feet, okay? Like the feet are also used in some controls, in some machines, okay? Now it depends on what kind of machine it is and what is the need. Do I need to allocate this control to the feet or to the hand? There are certain rules, okay, you need to keep in mind. So when do you, to use in your design hand controls and when to use foot controls, okay? So in general, the general rules for when to use a foot control and a hand control. Now, the hands, you can, with your hands, what can you do? And what can you do with your feet? Now, the hands can do more accurate work. So if I want something very accurate, okay, to control with my hands, I can do that. My feet cannot do very accurate controlled movements. On the other hand, my hand is weaker than my feet. So if I use my leg, it's stronger than my hand, but the work is not that accurate. Also, if I have to, for example, the control that I have to use, if I have to use it for a long time and I have to keep pushing a certain amount of force, again, because my hands are weaker, I will get tired. But in this case, it's better to allocate the control for the legs to do the job, okay? So, for example, in this bicycle, if you look here, what do we have? Hand controls are used for these controls, okay? The hands are used for these controls and the feet are used for these, the pedals. Why? Because using the hands for the hand controls, you need a smaller force, you need accuracy to drive the bicycle, and you need fast reaction time. Now the feet, here, the pedals, you need a large force, okay? You need little accuracy for this and slow reaction time. So imagine if the hands had to be on the pedals. If you had to pedal with the hands, it would be impossible. You would need to be really strong to do that. And after a certain time, you will really get tired. So these should be done with the feet. These should be done with the hands, for example. Now, in devices, also, it's the same thing. You need to think. Now, most devices use the hands, most devices, but there are some devices where you need extra strength or less accuracy. Then it's better to design the device in a way to do the hard job, to be allocated to the feet, okay? Now, when we talk about controls in general, we can divide them into two types. Why do we need to know this? Well, because each type has its own characteristics, its own use. So when I use, for example, a discrete control or a continuous control, the way I use it is different, okay? And well, for some tasks, it is better to have a discrete control. For other tasks, a continuous control. Again, it depends. What are the tasks that you need to perform and what is the device function? So, to better understand how to analyze controls, like if I look at this device and I want to analyze what are the mistakes in these controls, or I want to design a new device like this with well, basically solving the problems that exist in these controls. Well, I need to know first, what are the types? Like, okay, I need to know that some controls are called discrete, others are continuous. Then I have to decide, okay, is this control, for example, should it be discrete or continuous? Now, what are they? What is the meaning of discrete and continuous? Discrete means you have a limited number of conditions. For example, switches or controls that have only two options, for example, on, off, like light switches, or even these. You click and you click, okay? So this is a limited number of choices. A continuous control is, for example, something like this, okay? Where you have a lot of choices, okay? And continuous means you rotate, okay? So for example, like this one, on-off buttons are called discrete. They have very limited choices. It's like only this or this. Continuous means you can rotate it. Like for example, a washing machine. Often you will see a continuous control with many choices. This one also has it. Now, some continuous controls, when you rotate, it rotates in a smooth way. So you need a lot of accuracy and, you know, decide where you want to stop. Some have like clicking sound. Look. So this, for example, this is a continuous control, but also discrete in a way. So this is mainly continuous because you have, but because it has very specific choices, you know, like when I click this one, I cannot go in between the first and the second. No, it's this or this, then or this or this. So this is kind of both in a way, but some continuous controls, when you rotate, they're very smooth, you know, in the rotation. These are totally continuous. But in general, keep in mind, if you rotate it and you have a lot of choices, call it continuous. If you have a discrete, like on-off buttons with two limited choices, for example, call it a discrete in general. So, what makes controls effective? Okay, so let's say well-designed, okay, effective for use. Now, accessibility, so they have to be accessible, identifiable, and usable. These things makes a control good as design, okay? Now, what do these three mean? Accessibility. Now, we said that all controls will come in contact somehow with the human body. Most controls, you need to, what? I need to touch them, okay? So they will come in contact with me. Okay. So since this is true, then accessibility in this case means that I need to be able to reach them. Now, some devices are, you know, very big, you know, very big devices, and the accessibility here means to reach the control, okay? Can you reach it or not? Comfortably and efficiently. So you need to be able to reach it, to reach the control in a comfortable and efficient way. This has, again, to do with the size of the human body compared with the size of the machine, and so on. So what machine are you designing? Some machines are small handheld machines. Then you would say, okay, well, obviously I can reach all the controls if it's a small machine. Well, you are wrong, because even if I use a small handheld device, this is a machine, okay, a handheld device, a mechanical system. Now, we have controls, okay? Well, this is a mobile, right? Okay, I have controls. Here I have the on-off button. Here is the control for the sound. Here I have a few other things, okay? So now, you need to understand that even handheld devices, they are designed to be used and to be held and used in a certain way. So look how they designed this button, for example, okay, the on-off button. So if I put my mobile in my hand, I can perfectly reach it with my thumb, okay? Look at the size here and my thumb. I can comfortably reach it. This means this button is accessible for me, for the body part that I should reach it with. So it's not only about, can you reach it like this? No, it's when you put the device in your hand, can you reach the buttons, the controls, the way you should? Okay, I can reach, okay, I'm opening my mobile. Now, what's inside here? I can control with my thumb. I don't need to use my other hand, okay? Also the sound, the upper button here, the sound up, the sound down, okay? The volume. Everything I can reach with one hand. So I can operate my mobile with one hand. This is very important. So the way the controls are placed are so that I can operate it with one hand. Because I really need to do that often. What if it's designed in a way that I have to use my other hand? It will kind of create some limitations in the use. Limitation. So I have to use both hands, which is not practical always. So accessibility does not mean only reaching something with your whole body. It means also with the hands and with the fingers. Can you reach the different things, the different controls in an easy way? Are these controls accessible for whatever they're designed for? This is a mobile. Another device has other needs. So the human hand will have to reach other things, other controls in a different way. So accessibility can be in a bigger scale, talked about, and in a small scale. Even small devices could be non-accessible. The controls could be not designed accessibly, to be accessible. So don't forget, even though we're talking about small devices, that doesn't mean that, oh, yes, I can reach everything. It's not like that. It's how are you supposed to hold this device? How are you supposed to move your fingers around? It's the accessibility with each of these fingers. So you need to understand exactly how the human body moves and uses, performs a task. How do you exactly perform the task? And each device, the way the tasks are different and the way you move are different while using. So be careful. Accessibility is not so simple just to say, oh, it's accessible or not accessible. You need to explain everything. Why, if it's accessible, why it is accessible, which controls are accessible or not accessible, and why again. So when you have a project to do and you tell me, oh, my device's controls are accessible, that's not enough. You will get a very bad mark. You need to explain in which way are they accessible or not accessible? What makes them accessible? How are they accessible? How this relates to the human body? Everything you need to explain. Now, identifiable. They have to be, controls to be effective, they also need to be identifiable. So what is identifiable? So you need to be able, these are controls here, for example. What are these? These are controls, okay? So when I look at these controls, I need to be able to identify them. So how do I use them? The control should be able to tell me how should I use it by its shape. So the shape plays a role here. So when I look at this shape, look this circle at the back and this rectangle here, it's a 3D object, a form, but it communicates to me that, yes, I have to put my fingers like this and to rotate it, okay? It tells me by its form. Also, I need to identify, I need to be able to identify these. They have to be identifiable in terms of, okay, when I use this control, what happens here at the top? So this control is for which one of these? Which of these controls is for this? Which control is for this? Which control is, okay? This is also identifiability. Not only how I use it, to be able to use it, but also to identify for what is this? What am I controlling here in the machine? So it's a little bit unclear here, the way it is, I mean, the way I see it. So it's a little bit hard to identify this one, is it for this? Or this control is for this? This one is for which one of these, okay? So identifiability is this, telling me about how something, a control works, and also what am I controlling with it? So this is especially true when you have groups of controls that have similar functions. So all of these controls, their function is similar, okay? So look at all of these shapes, they're the same shapes because their function is similar. So for example, if this control is for this place here, it's this control has the same function, it's just for the other one maybe. Okay, this one is maybe for this, I don't know, but they perform the same function. So if I rotate them, they put, you know, they make this machine to work in the same way. So they have all the same shape, the same sizes, everything is the same. But you need to be careful that you still need to show, for example, each of these controls, what do they control exactly? You can't do that with, for example, the labeling. The label, there are labels here, labels, okay? Written information. So if I look at this label, oh, I see a black dot here. It's not very clear because it's a little bit small, but the black dot here shows me that this one is for that one at the back. This one here, the black dot tells me it's for this. So now it becomes a little more clear. So just looking at the controls, I didn't understand anything. But when I looked at the labels, things become a little more clear. So if you're a graphic designer, you are very much involved in the design of this, and they have to be very clear for the user. So you can use labeling to make the controls identifiable. You can also use the position of the control. Like, for example, look at this space in between these, and look at this space and this space. These spaces are big. These spaces are smaller. Why? Okay, they have to have a function. So the way I place the position, where do I put the control? Where do I put it? On this interface, okay? It's very important, and it can make it identifiable or non-identifiable. So, next, usability. A control, any control, should be able for you as a human to be able to use it, to be used. So you should be able to operate it, use it with the required force, speed, and accuracy. What's the, I mean, if you want to use a control and you cannot use it. For example, if I want to use this and rotate it and I need so much force to do that, I cannot do it, okay? Then what? It's not usable. There is some problem with the usability. So the speed, the accuracy, the range of motion, okay, everything has to be in a way that I can use it comfortably with my body, okay, with my strength, with my hand shape. Everything has to be designed for, suitable for me and for everyone else. So if you have to use, for example, to operate a control that's very hard to do by your hand, well, you will have a problem. This should have been designed, the device, to be operated by the feet, not the hands, if it needs that much strength and force. If a control is precise, okay, again, how do you operate it? How to make it usable for the hand? So this is very important. You need to ask yourself, is the control, the way you designed it, usable or not usable? Now, maybe you as a designer will create, will design a control that has a certain shape, you know, but when I try to use it, to grab it with my fingers, I can't. For example, let's say this device again. Now look at this here, this rectangular 3D object here. Now it has a height, okay? This height is put suitable for my finger so that when I grab it, I can grab it with force and enough force so I can rotate it. Now, if this height was too short, what would happen? If I want to touch it and rotate it, I will not be able to. If it's too short, the height is too short. This means it will not be usable. So everything you design must be designed taking into consideration the human body, whether it's the size of the hands, the fingers, the way you move your hands, everything, your eyes. When I look at a label, do I understand these labels? What do they mean? Okay. Everything has to be designed for the human. Okay, so effective controls, you need to take these three things into consideration. Now, whether you're analyzing a device for design mistakes, you will look at the controls and decide, are they designed accessible? Are they identifiable? How much are they usable? So this is analysis, and you write down the problems. Then, when you are designing, solving the problems, you will look at each one of these problems and solve them. So design a better, more effective controls. This is on the design stage. We said before what? Before the design stage, there is always an analysis stage, finding the problems, then solving them, okay? Now, a few important guidelines for the design of the controls. One of them is control compatibility. What does compatibility mean? The control should operate in the way that people expect it to operate. So, compatible controls are safer in emergencies. Now, compatible means that it should operate in a way that I expect it. So if I have a control that goes, for example, on, off, naturally I expect that on will be to the top. And when I press it down, it will be off. So I expect certain movements, like for example, this is not a device, but it's also an example, like the door handle, okay? Now, when you want to open a door and you take the handle and you press down, oh, here we have a door handle. Do you see this door handle? So when I press down, I expect the door to open. I don't, now what if the designer designed this to have to pick it up to open the door? So I have to pick it up to open the door. This will be not natural. It will be against my expectations. My expectation is that when I press down, the door opens, okay? Now, most controls should be designed according to what people expect, what is natural to the operator, to the human, because this is safer, for example, in emergencies. Let's say if this door is designed to be opened by putting the handle up, and I don't know this. And now some kind of an emergency happened and I have to escape from this door. And I will start to pull down, and I think, okay, why does the door not open? So you must design controls most of the time according to what people expect, how people expect them to operate, okay? Because under emergencies, under stress, people will resort back to their natural behavior, the movements that naturally come to them, okay? Okay. And controls can also be used quicker and in a more easy way if they function the way I expect. So these buttons, I expect them to function how to operate this, by pressing. Oops, okay. So by pressing them, I don't expect to do this, to take the button out, okay? To take the control out. I expect it to function by pressing. So natural expectations of how something operates. This is very important. Now, sometimes there are exceptions in some designs. Like again, this door handle, okay? I can't design it to open by movement up, not down. This is in certain situations when, for example, let's say I have a home and I want to add extra security, extra, so that, for example, if a thief comes and wants to enter my home, the thief will think that the door functions by pressing down. But in reality, he has to put it up to open. So I can make things in certain situations, in certain designs, safer by doing exactly the opposite, by designing controls to function not the way the user expects, okay? But you must be very careful. In over 95% of situations, you design according to user expectation. Only in certain exceptional cases, you can do the opposite for certain designs, depending on the goal of this design. So control compatibility is one of the guidelines to design controls. Now, the use of force is another guideline that you need to be careful about. The maximum force, which means the speed, the accuracy, and the range of body movement, okay, the range from to, how much you can move the body to use this control, should not exceed the limits of the least capable operator. Operator means the user, the human. So, should not exceed the limits. What does that mean? So, a control should be able to be used by the smallest and the weakest of the humans, So, when we talk about anthropometrics and percentiles, this means the 5%, the 5th percentile, okay? So when you design controls, you should design taking into consideration the smallest size humans and the ones that are weaker, not the strongest and the largest. So that this machine can be operated by most people, okay? Even the smallest and the biggest, of course, but the smallest are important to be taken into consideration here. Also, controls should have enough resistance so that they can't be accidentally operated, especially when the consequences of this is very serious. So they should have enough resistance, So when I want to, what is the resistance? So if I want to rotate this, okay, I need to look, when I'm rotating and pressing, and the control itself is resisting me. So it's not very easy for me. It's easy, but not very easy to rotate. So the control is causing some resistance. This is why, so that accidentally I don't, for example, press a button or rotate. If there is no resistance, it would be easy to make a mistake. This device, okay? Now, when I press a button, when I press it, I need to apply a certain force to do it. It's not a lot of force, but the control is designed with a certain resistance, so it's resisting me, okay? This is very important for not to click accidentally. So if I now put my hand like this, or like this, or like this, nothing happens. Look, nothing happens. But if I click a little bit harder, then it's operated. So I can take this device in my hand like this, or like this, touch it. Nothing happens. Nothing happens, okay? So I cannot accidentally click these buttons easily. But if there is no resistance, like in touch buttons, okay? So if I open my mobile now, look, these icons, okay? If I just move my hand over them, okay? I can very easily operate something that I don't want. These are touch controls, okay, with touch. And the touch is very sensitive, okay, very sensitive. So I must be very careful not to touch something by mistake. So how much resistance do controls have? Touch buttons do not have any resistance. So other things have to be made in the design of touch buttons to make them safe, so that, for example, you don't click by accident the phone icon and call somebody by accident. It can happen. Let's say if I put this in my pocket, okay, and the icons are here, very easily, just by doing this on my clothes, they can, oops, yes, they started operating, you see? So with touch buttons, the design has to be made in a way to prevent this accident from happening. When you have other buttons like these, the resistance that you can design in each of these, this helps to prevent accidental operation of the buttons. Now, for controls that you need to continuously operate, continuously use for long periods of time, the resistance should be lower. Because if you have too much resistance, you will make the human get tired. I mean, if the human has to use it all day long, a certain control. So, again, it depends on what is the machine that you are analyzing or designing, and what is the task that needs to be performed by the human. So this influences what type of controls you should design, how much resistance should they have, should they be touch or, like buttons like these? Should I design them discrete or continuous? Should I allocate them to the hands or to the feet? Or so many decisions to be made, okay? But in general, the use of force, you need to consider it a guideline in the design of controls. So without considering this, the control will not be successful the way you design it. The coding is another guideline that should be used in the design of controls. Now, you can code controls, code them in terms of shape, the size, the mode of operation, the labeling, the color choice, many things. All of these are coding, okay? These are coding. Now, if we talk only about shape, this is shape coding, okay? Later, we'll talk about size and the other stuff. Now, shape coding. So the shape of this control, the way you design it. Look, this shape is different than this shape, and this is different than this shape. Now, this can, by changing the shape of the control, I can make it more successful. So the human can, for example, understand by looking or just by touching. Sometimes I don't even have to look at a certain control because I recognize that this shape is doing this function. So if I touch this control and I already know what its function is, next time when I touch it, I don't need to look at it. I know, okay? So visually and sensually, it's important, the shape of the control. To what? To identify the control. What is this control? What does it do? Now, be careful. Most of the time, standardized shapes are used. Do not go crazy with the shapes of the controls, because sometimes if you go crazy and design all kinds of crazy shapes, this can create more confusion to the user. You should keep to the simple shapes as much as possible, not go to the crazy. For example, you don't put several controls in one device and, for example, do this a different shape, this a different shape, this a different shape. No, you have to exactly know what is the function of these, what is the function of this, what is the function of these. Look, this shape is different than this shape. This is a circle. This looks like a, well, I don't know what the shape is called, but like a rectangular with the soft edges. So why are these two the same shape. Why is this the only circle in this interface? And why are these controls, all of them have the same shape? Well, we will see that later. I will discuss it again, but it depends on their function. So this one immediately I can recognize is the on-off button. Now these two, because they have the same shape, they must be related with function. So their function must be similar. Also these, because the shape is the same, I understand that their function is also similar. They have differences, but they have, as a group, they are similar. That's why the designer made them the same shape. So shape coding, it's very important to know, again, what is the device you're designing? What is the task that needs to be performed? What do you need the human to understand? Should the human always be looking at the control, or do you need the human to understand the control just by touching? Like for example, the airplanes, they have a lot of controls inside, basically the cabin. So all of these controls, they can be overwhelming if you have to use 1,000 controls or more around you. So the shape coding can be critical. And some of the controls are designed with very specific shapes, so that even if I don't look at them, because I need to look at somewhere else, to focus, to concentrate on something else, I can just touch them and I can understand this control by its shape, what it is, okay? So the shape can play a big role, what shape you decide to design your control. It can become very confusing or very clear to the user. The size also plays a role. What size do you make your controls? What size exactly, okay? Now, the rule is that the larger control should always be at least 20% larger than the smaller one. Because if I put like this control next to this control, and if this control is not 20% smaller than this one, when I touch them, I will not recognize the difference. I can make a mistake because they are very close to each other. So if this one was bigger, okay, close to this, by touching, I will not know. Am I touching this or this? So for this to work, the smaller control have to be 20% smaller than the bigger one, and this one, again, the same thing compared to this. So this is to avoid what? Confusion in selection. Because then I can really recognize this is different than this, this is different than this. But if they're very close size-wise, it can create problems. I will not be able to identify them correctly, whether with eyes or with touch. So be careful of the size. Also, the size can give you meaning to the control. Like if I make a control bigger, and even if it's the same shape, even if it's the same shape, if I make one smaller and one bigger, it can mean different information to the user. So the shape, very important what you choose. And the size, very important, okay? The color also is very important. So what color do you put? What color? So here we have all of them at the same color. Here we have different sizes, again, the same color. But if I change the color of this, or if I change the color, it will start having a totally different meaning. If I choose red, very different than if I choose green, or white, or yellow, or black, okay? Now, all of these work together. You cannot, for example, expect to choose only the correct color for a control and to expect it to be clear. No, it's the color together with the size, together with the shape, that either makes the control clear or not clear. So you cannot separate these, okay? in a real device, all of them have to be designed carefully. What shape you choose, what size, what color. So you need to go back to the what do these colors mean, the psychology of them, the things, you know, that we discussed in the basics classes, the basic classes. These are all elements of design. Color is an element of design. Size, okay, we discussed that as one of the principles. Shape also is an element of design. So now, so certain colors have certain meanings for the user. If I see red, it's different than when I see green, okay? Psychologically, meaning-wise, everything. You need to be very careful what colors you choose for the controls. Now, also you need to be very careful if you use color in controls. This should never be the only thing that lets you recognize or identify the control, because sometimes there are colorblind people. Now, when you're colorblind, when you look at the certain colors, you see them in a different way. You cannot see all the colors. So if I'm a colorblind person and I look at the controls, I will not understand what's going on. If this is the only method used to communicate to me, so we need to have labels maybe, so I can read, what does it say? We need to have the shape to play a role. We need to have sizes. We need to have everything designed correctly so that even colorblind people can operate it, can operate this device correctly. So now we will talk a little bit about the ergonomic functions of color. Color is really a complicated topic, and it's very deep. So we cannot just stop at this. We need to discuss the ergonomic functions of color. So we can use color for safety. Okay, so we can use color in a specific way, specific colors, to improve the visibility of potential dangerous components. Here, contrast must be used. What is contrast? We already discussed it in the basics of design class. Go back and check your lectures in the principles of design. So now, using color to create safety by improving the visibility, by using contrast and certain colors. So I can make the user understand that this, for example, control is like danger. You know, you have to be careful about it with certain colors, okay? The visibility, the way you color controls, which colors you use, and color combinations can improve their visibility so you can see them better. So if you want, again, we discussed this in the principles of design, how to make something to stand out from the page. If I use everything, for example, black and white, and I use red here, okay? This makes it stand out, okay? The same with the controls, okay? The same. So if I want to make certain controls to be more visible than other controls, it's the choice of color that can play a role. Of course, the shape too, the size too, but the color is very important. It's very important element of design, okay? So color also can help you distinguish between the various functions of controls. So the color can make you understand this control functions in a different way than this one, just by the colors used, the different colors used. Now, if you use the same color, it will tell me that they function similarly, especially if also their size is the same and their shape is the same. This will even more accentuate that the message that they are the same. But if I use different colors, immediately this tells me different function, okay? It tells me in my mind they function differently in some way. Durability of appearance. This is also an ergonomic function of color. Now, most of the products, devices that you will use with your hands. Okay, I'm touching this all the time. Okay, what is this? A mouse. I'm touching it all the time with my fingers. Now, also the environment in which you will use this device can influence also this. So now color here, the choice of color you use for the device can help, okay, in this kind of situations. When you, for example, overuse a device with the hand, over time, the color maybe start fading, okay? So how can you choose the correct color? So even with time, with fading, with overuse, it will still look acceptable. So also, the durability of appearance. You can make a device look more durable by the choice of color. Durable means what? Strong, powerful, you know? So if I use certain colors in this device, I can make it, for example, look very soft, very sensitive, or I can make it to look very strong, very powerful, very durable. Look at this example here, okay? Now, not only the color plays a role, not only also the shapes, okay? But just look at the overall shape of this. Not only the controls, the overall shape of this device. This is a mobile. Our mobiles don't look like this. This is designed for durability, okay? Now, it can be designed to look durable, or it can be really durable. So is it really durable? Does it break easily? Or is it just designed to look durable? Because you can choose certain colors, certain shapes in a design to make a design look durable, strong, but in reality it's not. Or you can design the shapes and the colors to look fragile. Like I think that if I drop this on the floor, it will break. But I can design it in a different way to look strong, but it's actually the same strength. It's just playing around with human psychology, okay? And sometimes it is designed to be durable. So it is really designed very strong. So it depends. Now, but we are talking here about the color use in this case. So what colors we choose can make something look stronger than it is in reality, or weaker than it is in reality, a device, okay? So the color is very important in this choice. Now also the shapes, also everything, but the color plays a major role. Now if this was not gray, but let's say a very soft pink color, okay? Or a very soft yellow, a pastel color, this will immediately lose its a big percentage from the way it appears, the strength, the durability. It will lose. It will appear softer now. So the color is very important in appearance of durability. Identification, okay? Now, colors are associated with various standardized products. At times, this can be for commercial reasons, like to, for example, for people to be able to recognize the brand. What is a brand? This is, for example, a brand, Bosch Power Tools, okay? Like this is the brand, Bosch. So if you look at all these products, the colors used, notice the colors, okay? Now, the controls are here. This is the control. They're always with red. Do you see these controls? They're always with red. Even the whole product, look at this color, okay? The blue, the black combination, the red, blue, black, and metal. Now, colors are used to what? To make you recognize brands sometimes. So if I see these devices, I know immediately they are Bosch, okay, for example, because of their colors. Now, another, for example, machine, the same machine with this function could look, the shape could be very similar to this, but because the color choices, I can recognize this is this brand and this is for another brand. So color choice can influence the brand image, can make people remember Bosch brand. And companies want you to remember brands. It's like, okay, if you don't remember this brand, you will not buy these products. Companies want you to buy, to remember what is associated with this brand. What do you know about the devices and this brand? Okay, made by this. So if you have good associations, if you know this is a powerful, a good brand, good design, then from far away distance, you can see a device and you know this is Bosch and I want this, okay? So the brand image is very important for companies. And also for identification, like also to identify, for example, if we're talking about controls, to identify the controls, again. So, but here we are mainly talking about the brand images, you know, the recognition. Companies use certain colors to make people remember this company, this brand, okay? Now, standard component colors for push buttons and indicator lamps. Now, in general, standard component colors. I will not go over in detail here, but you need to know that there are some colors, okay? Some colors, we're talking about color here, that is used in a standard way. That means if you see them used here in Jordan, you will see the same in Europe, you will see in China, you will see in everywhere they use the same colors for this function. So, for example, for push buttons, where you push this type of controls, red is used for stop, if you want to stop something, or on off, okay? Stop all or stop part of the machine, and so on. Yellow, for example, is used for certain cases also. Gray, blue, green, white. So there are standardized colors. You cannot use red for example, if it's not one of these situations. Or let's say I want to put here, instead of red, I will put green. I will use the green color. You will confuse the user, okay? If it's a stop button, it needs to be red everywhere. The same thing with other colors, and the same thing with indicator lamps. Sometimes you have next to the control a lamp. This is the control. These are indicator lamps, okay? Now, look, they are also colored. We have green, then we have going towards other colors. So, what does that mean? Okay, so not only the control have standardized colors, but also the indicator lamps. So if you make a lamp red, it obviously means danger. If it's green, safety. You cannot exchange their place, okay? So, but these tables, they can become really complicated with more colors, with more choices. If you're really designing a device, you need to look into more details. This is a simplified version, only to give you an example that there are standardized color use in the design of controls. But you need to extract more information when you really are designing this. I need to know everything about it, not only in general, okay? Color can also play structural functions in control design, okay? So it can affect, structural function of color can affect the capacity to which, how the object is perceived, how the object is seen by the user. It can, for example, by using color in a specific way, you can center the attention, focus the attention of the viewer on certain aspects, on certain controls, for example. Now, look at this one. This control, it's circular, it's very big, and it's blue. Look at these two controls here. They are small, but they are red. So what does this, why the designer made this in this way? Obviously, there has to be a reason. It's not about just to make it beautiful. It's about the message that it's telling the user about these controls. The color choices. Okay, why is the background gray? Why is this white here? Or very light gray, actually. Why is this black? Why are these black and the same size and the same shape? Why are these the same shape and the same size and the same color? Why are these red? Why is this blue? Why is this white? So this, even though it's a three-dimensional object, a device, okay, when you look at it, if you know the elements and principles of design, okay, you already can talk about it, okay? How can you analyze this according to what information it gives to the viewer? When you have something of the same size and shape and color, it tells me something different than if I have this to compare it with this. They are the same shape, but different sizes, different colors. So why? Okay? Always you need to ask why when you make a decision, and it must have a very good reason. In controls, okay, well, you have to pay attention to the guidelines that we talk about, to everything, so that you know how to design this correctly, what color to choose, what shape, what size, to give the correct perception to the user when looking at it. So it can center the attention. Centering of attention can happen when you use contrast, for example, black, white, okay? Or very high contrast, even this gray with this red, it creates contrast, okay? Color can also be used to camouflage. Camouflage means to hide something. So if I use very similar colors, well, it's not the perfect example, but look at these white buttons here over this, I would say, white, milky background. It's a little bit not clear, not very clear, especially if you look at it from a distance. Look at these colors with the background color. It's like camouflaging them. It's not making them stand out. Only this, because it's a red, well, orange kind of color, this background here, this makes this button, you see this button, to stand out. So it grabs my attention, this one, because of the background, which is red, orange. But this, the white on the milky background color, it's kind of camouflaging them. Now, camouflage can be used, it depends. Do you need to camouflage something and make something else to stand out? It depends again. What are you designing? What is the device? What is the function of them? What are the tasks supposed to be performed by the user? So you know which parts to camouflage, which parts to make to center the attention or to stand out. It can create also, color can create the separation and association also. So you can use color to separate something. It's not really separated, but using the color, you can make it look like separated. Like, for example, look at this button here, this control. Do you see it? Look at this background, black color. Now, what is the function of this? Now, if you remove it, imagine it's not here, okay? This will not stand out that much. This here, the shape at the back with this black color, it makes a separation between this control and the other controls and displays, okay? So we have here other controls. So it's like it's separating it through the use of color at the background. Now this can be color you can use at the background and at the foreground, okay? It goes both ways. Now, look at this machine compared to this machine. This button here also has this here background, black color, which is also, in this case, it's also a display, okay? So it functions as a display, but if the display is not working, it creates a separation between this and the rest of the shapes and controls and what's going on. Because when you look at this, you look at them as shapes. I look at this as a composition of shapes, okay? Visually, I look at it. Composition of shapes. So how are they organized? Okay? The colors clearly sometimes separate. Like what is this here? Two indicator lights, I believe. And look at this back, this like rectangle behind them, the black rectangle. Why is it put here? What's the function of it? What's the function of it, okay? Now, there can be several reasons, but it can be also to create separation or association. Like this is part, for example, of the device is separated than the rest, or association, like it's associated somehow to the rest. It mingles in. So where are the boundaries? Also, if you manipulate the strength of the boundaries between the colors, this can create also very strong separation. Like this is the boundary, okay? Like this is a very clear line, okay? This is black, this is gray, very, very clear. And the boundaries are very clear. Sometimes you can mix in colors, one color to flow into another color, so the boundaries are not clear. Again, this is correct and this is correct. It depends where you use it, how you use it, and what kind of device. And where do you use it in the device? What is the main shape of the device? What is the shapes inside? With the colors, everything together, all the elements, okay? How do they interrelate? So, proportion and orientation. What is proportion? We already discussed it in the basics of design class. When we compare, we know this size, for example, is small because we compare it with another size. So proportion, the proportions of all the elements inside compared with other elements, okay? So the visual proportions, visual means the way they look, the proportions can be enhanced or altered through the use of color alone. And also the direction can be shown through color. So for example, look at this, the way the color divides between the white area and the black area. Now, if I did a different shape with the black, it would change all of the proportions and everything about this device. What if I did this longer, like covering like this, okay, and going over? So again, only these two colors, but the way I do them can change the result, the way the device looks, okay? So you can have two totally similar, the same devices, just by using the color in a different way, you can change the look of the device. So you can change the look of the proportions of certain controls, for example. You can make certain controls look bigger or smaller, depending on what color they have and the background has, okay? And the orientation. Like, look at these two lines here, the way they are made. It's kind of moving our eyes in a certain way. Also, I feel because of this white color, it creates a different sense, a different weight than this area here. It makes me feel that which way is it correct to use the device, this way or the other way? So it helps me understand something about this device. And also it's visually pleasing or not pleasing. Is it beautiful, not beautiful, aesthetic or not aesthetic? So by changing the proportion of the way elements in this device look, in this case, we are focusing on the control. So you can change the proportions of the controls through the color use, through what are the color of the control and what is the background color. So this can play a big role in the way the device looks in the end. Now, we finished about color. We will talk a little bit about the labeling now. We are still on the coding of controls, okay? So we are talking about labels now. These are the labels, okay? They can be with text or with certain signs. This is also a label, okay? These are labels. So if you label a control, why do you need labels sometimes? To explain the use of the control, the function of it, how, so you're giving extra information to the user. So if you use label, you need to be careful about the space, okay, between the label and the control, not to cover it. For example, if I'm using a control with my hands, when I'm using a control, not to cover the label or make it unclear, or so where do you put this label? Do you put it at the bottom? Do you put it at the top? Do you put it at the side? This has to be decided also. It's not a, do you put it on the button? Sometimes you have the label here on it, okay? So many places where you can put it, and so many labels. What font do you choose? What font style? What type? Is it uppercase, lowercase, bold, not bold? What color, again? What color is the text? What color is the background? What color is the sign? What color is the control itself? So how does that play together with the label, okay? So if I want to put a label on it, how can I make it visible? Maybe by using contrast. So it's a lot of things to decide regarding label. What kind of label to design for this control? There is also standardized, sizes of fonts that can be used, and colors. So it really, it's like thousands of options depending on what is the device, what is the control do, what is its function, what tasks are performed, what is the body movement while you use the control, is it on off, is it the continuous control, so what is the color, then the labels together with this, how does it function? So how to design the label? It is also an important question in design of controls, to make it clear, to make it understandable, to make it identifiable, the control. So to make the control effective, and we discussed what is an effective control above. What makes effective control? Always don't forget, when you design controls, to know exactly what are the tasks going to be performed by the human. This is very important, okay? The tasks performed, and how do you perform it? How do you use your body? Which body parts? What are the measurements? Okay, everything needs to be considered. And often the quick identification of controls can sometimes in some devices be critical to life. So we know that in ergonomics, one of the main things, one of the very important things to always consider is the safety. The safety is very important. So if you just by designing the controls in a wrong way, you can create safety problems in some devices, especially when the devices are dangerous and have a lot of controls. So these machines have a lot of controls. So when you have to design 1,000 controls in this machine, it's much more complicated than if you have 1 or 2 controls that you have to deal with. So now just another comment to make, which is important, that what advanced technology, basically nowadays, what kind of a role it plays in controls. So it basically opened a lot of possibilities for controls as a design. So these days, we not all controls are just, taking a device and pressing or rotating. No, you can, for example, use speech talk to the device. For example, I can tell my mobile, search, for example, on the internet, this and this. I can say the sentence, and here the text will appear. So I don't have to type it, So this is also a control. Speech can be used as a control. So I'm using speech to control my device. Also, eye track movements. Some devices are advanced, so advanced that, for example, I can use my computer only with my eyes. I can look, for example, at the keyboard with a certain amount of time. at a letter, and it will appear on the screen. Okay. So then I can look at another letter. So the computer recognizes my eye movements and can type for me. So this is also called a control. So controls do not have to be only discrete or continuous controls, okay, where you rotate. No, they can also involve speech, eye movement, and so many different ways, because nowadays we have a more advanced technology. So also the control types that you can choose are not only limited to these movements, okay? Just to consider. Now, the devices that you will come in contact with in your daily life will mostly involve the traditional controls. But many mobiles that maybe you have also can also already recognize speech. So we have also this control in our daily life. Okay, we don't need to have very advanced machines, okay, for this. Okay, this is it for today. Have a nice day, study the lecture, okay? And I will see you next time with talking about displays, okay, in more detail. Okay, bye-bye.